Okay, class, welcome to part 2. There are 2 more questions left, so it should not be long. So we're going to solve this equation on the it's just the solutions on the unit circle. So for this, we see that sine of x plus 1 equals cosine of x, and we don't have any trig functions that we can factor. We can't use the Pythagorean identity. There's nothing we can do. So the trick here is we can square both sides. So the left-hand side, remember when you square it, we're going to write it out twice. So we have sine of x plus 1 quantity times sine of x plus 1 equals, well, cosine of x quantity squared is the same thing as cosine squared of x. So we're going to either use the box or the FOIL method. So first gives us sine of square root of x, outer gives us sine of x, and inner gives us sine of x. So that's plus 2 sine of x, and we have 1 times 1 is plus 1 square root of x. So the reason we squared this to begin with, because there was no factoring or distributive property or Pythagorean identity that we could do on it. So the trick is, now we've introduced a cosine squared, and so when we can replace this with the Pythagorean identity. And remember, for the Pythagorean identity, cosine squared u plus sine squared u equals 1, or cosine squared u is 1 minus sine squared u. So I'm going to replace cosine squared with 1 minus sine squared u. So the left-hand side is going to be the same. We're not going to factor it yet, because we want to factor it once we set everything equal to 0. So all I did was replace cosine squared x with 1 minus sine squared x. And then I'm going to subtract 1 here, and I'm going to add sine squared. So when I subtract 1, the 1's go away. When I add sine squared to the other side, I end up with 2 sine squared x plus 2 sine of x. When I subtract 1 here, it goes away. So now I set it equal to 0, and once you set it equal to 0, then you can factor. And I have a 2 sine x and a 2 sine x. So I'm going to use the distributive property by pulling out like terms. And when I pull a 2 sine x, I have to multiply it by sine x to get that squared. So 2 sine x times sine x is 2 sine squared x, plus 2 sine x times 1 gives me 2 sine x. I'm going to set each term equal to 0. Sine of x plus 1 equals 0. Sine of x is negative 1, and then divide both sides by 2, you get sine of x equals 0. So I'm going to look on the unit circle for sine, which is the y-coordinate. I want the y-coordinate equaling 0, which is these two angles, and the y-coordinate equaling minus 1, which is down there. And that would be all solutions between 0 and 2 pi. So my angles x from sine of x equals 0 would give me 0, pi, and 2 pi, and sine of x equals negative 1 gives me x equals 3 pi over 2. So those are all my answers, and I'm just going to write them in numerical order and put a box around it. And that is the problem. So let's move on to the next one. Okay, so this is our last problem, and there is a perfect we're solving x. So we'll see how that differs. So first we're going to isolate it, our tangent, and we have tangent of x over 2 equals 1. So we know where tangent of x equals 1 if we had x. I'm going to use u just for now, just to make sure we have a different variable. We know it's the pi over 4 angle, so it was when u equaled pi over 4, and it was 3 pi over 4. That's where tangent equals 1 and negative 1. Technically, I guess, at 3 pi over 4, it equals negative 1, and that's not one of the possibilities. So it's just pi over 4 and 5 pi over 4, because at 3 pi over 4 tangent, which was y over x, was negative, and at 7 pi over 4, you get negative. So it's just pi over 4 and 5 pi over 4, which are all pi apart. Okay, so it would be pi apart. So if it was just tangent of u, we would say pi over 4 plus pi n, and that would give us all of them. So we know that our angle x over 2 can equal pi over 4. So then you have to go ahead and multiply both sides by 2 so that you get x is pi over 2. Again, multiply by 2 and you get x is 5 pi over 2. So instead of them being pi apart, well, now we have pi over 2 up here and 5 pi over 2. Well, 5 pi over 2 was, we have 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and 5 pi over 2 is up there. And they are a multiple of 1 full circle away. So we know that it is x is pi over 2 and 5 pi over 2. So we have 1, 2, 3, 4, 1, 2, 3, 4, 5 pi over 2. It keeps landing on the same thing. So it's pi over 2 plus 2 pi n, and that would be all possible solutions. Relating this 2 pi n back here, remember x x over 2 was pi apart. So if we multiply x over 2 by 2 and this by 2, we get the 2 pi. So it's the same idea. So these are a little trickier, and they do require practice, but we'll be seeing those in our classwork tomorrow. Have a good night.